Down there, life continues. The
day, grade 8 learners. Welcome to today's natural sciences lesson. My name is Pathuchetso Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area energy and change. The main topic is visible light, and the subtopic, which is what we're going to be learning about and focusing on today, is opaque and transparent substances. Now, let's look at today's lesson objectives. So these are the goals that we're aiming for today. So at the end of the lesson, you should be able to describe opaque and transparent objects, distinguish between opaque and transparent objects. So we need to know the differences between the two, and then distinguish between different colors and the effects they have on different objects. And then lastly, we need to explain how we can see the color of an object. All of this is sourced from the CAPS document on page 50. So you can go right on and look at the CAPS document. You'll find these points on page 50. So pre-knowledge. Pre-knowledge is what we've learned prior to today's lesson. So it has laid the foundation of today's lesson. So what did we learn? So in the 7th grade, we learned about the transfer of energy, mainly solar energy. And then in the 8th grade, which is our previous lesson, the lesson that we had last week, we learned about the sun as the source of light. If you remember, we learned about radiation of light and the visible spectrum of light. We learned about those two as well. So those are the basis of today's lesson. Okay, so now let's move on to the baseline activity. I've prepared 3 questions for you. I'm going to read them out, and then after I read them out, I'm going to give you time to answer them. Don't forget to send in any questions that you may have and the responses to all the activities that we're doing to our WhatsApp number on 079-578-2908. When you do send in those responses, please state the name of your school. So question number 1, how many colors does the visible spectrum have? Name them. Number 2, what are the 3 primary colors of light? And number 3, which color light has the longest wavelength? So I'm going to give you 3 minutes to answer these questions. Then after 3 minutes, we will do the corrections together. Welcome back, grade 8. Now let's do the corrections together. I hope you are sending in the responses. If not, please have your pens and pencils ready for the corrections. So let's look at question number 1. How many colors does the visible spectrum have? Name them. So this is a two-part question. The first part of the question is asking us how many colors there are. And then the second part of the question is asking us to name them. So, yellow, green, blue, indigo, and violet. There are 7 of them. Roy G. Biv. Remember the acronym from last week? Roy G. Biv. The second question. What are the 3 primary colors of light? What are the 3 primary colors of light? A clue is that the 3 primary colors of light are also included in the first 7. So what are they? Let's see if you remember. It is red, green, and blue. Red, green, and blue. Those are the primary colors. If you wrote that, you can give yourself a mark. And then the third question is, which color light has the longest wavelength? Which color light has the longest wavelength? Remember, one way of differentiating between the colors of light is their wavelength. Do you remember how we're measuring wavelength? Okay, let's find out the answer. So the answer is red. Red has the longest wavelength. Red has the longest wavelength. Okay, now that we're done with our baseline activity, let's move on to terminology. So these are the terms that we're going to be constantly using during the course of the lesson. So it's good for us to know their meanings before we start our lesson. Now, the first one is opaque substance. What is an opaque substance? It is a substance that blocks the path of light. So when you hear opaque substance, think of a substance that blocks the path of light. And then what is a transparent substance? A transparent substance is a substance that allows light rays to pass through it. So these two are actually opposite. One blocks the path of light, and then one allows light rays to pass through it. So now we know that opaque and transparent substances are actually opposites. So now let's begin our lesson. Let's learn more about these opaque and transparent substances. So an opaque object, as we have defined in our terminology, is an object that does not allow any light to travel through it. Can you give an example of an opaque object? Can you think of an opaque object? Examples are your cell phone is an opaque object because it doesn't allow light rays to pass through it, it blocks them. Look around your classroom. If you're in a classroom right now, look around your classroom and send us different examples of what you think opaque objects are. You can send those examples to our WhatsApp number, which is actually at the bottom of the screen. If you can't see it, I'll read it out for you. It's 079-578-82908. So give us different examples of what you think opaque objects are. Remember, here's a clue. A clue is an opaque object does not allow any light to travel through it. I've already mentioned a cell phone. You can think of any other. Just send them right through. Okay, so if you remember from our previous lesson, we learned that light travels in straight lines. Light travels in straight lines. So when light rays strike the surface of an opaque object, the light rays are blocked. Remember we said opaque objects, they block light rays. So when it reaches an opaque object, those light rays, they are blocked. So the light is then, once it reaches, either it is reflected or it is absorbed by the opaque object. So if the light is absorbed, which means the light won't be able to travel any further, it's a dead end, it will not be able to travel any further. Once it has reached the opaque object, it won't be able to travel any further. That's it with that light ray. Now, so light rays that are wider than the opaque object will carry on around the object. They will carry on around the object, and that causes what is called a shadow. It causes a shadow to form. I'm sure you've seen your shadow during the daylight. You've seen your friends' shadows. You've seen shadows of other objects as well, cars, houses. You've seen them. So like that, because of that, it's light rays that are wider than that object that is opaque, that light is failing to travel through. So they cause a shadow to form. So where that area where the light is absent will appear to the back of the eye. So now let's look at this person who's making shadow figurines. Who's making shadow figurines. Now, so when the light, remember light travels in a straight line. So light is coming from this end. So this is where the light is coming from. So light travels in straight lines. So all the light rays that I'm drawing now with my pen have been blocked. So once they are blocked, a shadow forms. A shadow forms because of the light rays that are able to carry on around the object. In this case, the object is this person's hand. The object is the person's hand. So what are shadows? Shadows are darker areas that form behind an opaque object because the light is not able to travel through the object. So now I'm sure you've learned something new. I'm sure you've been seeing, you know what a shadow is. You've seen a shadow before. So now you know a shadow is actually a dark area that forms behind an opaque object because the light is unable to travel through the object. So that is what we call a shadow. Okay, so I've got more bottles here that are casting shadows. So they're facing the light source. The light source is coming from the left. It's coming from this side here. So that's where the light source is. And the shadow is on the right. So now the shadow forms on the right. Why does it form? It is the darker area. I'm just going to try and trace out this shadow here. It is the darker area that forms behind the object. The object is this bottle. Let's focus on the one. This bottle is the object. So light is unable to go through the bottle. Let's say these are light rays. Light is unable to go through the bottle. So then a shadow forms. So one other special thing that you need to know about shadows is that a shadow will take the shape of the object. It will take the shape of the opaque object and it will form on the side facing away from the light source. Remember we said the light source is in this picture is on the left and it is forming on the right. So the shadow will take the shape of the opaque object. You see it's got the shape of the bottle. If we check the second bottle, third bottle, fourth bottle, and fifth bottle, we are seeing the shape. If we come here and look at this picture in particular, this person is making the sign. It's making the sign. So the shadow is actually also taking the shape of the opaque object, which is the fingers of the person who is making the shadow doodles. Okay, now, so when objects are far away from the light source, a smaller amount of light is blocked and therefore a shadow is smaller. So we've learned two things, what a shadow is and that the shadow takes the shape of the object. Now let's deal with the size of the shadow. It is said here that when an object is far away from the light source, so when the light source is quite far, when the light source is far, a smaller amount of light is blocked, therefore the shadow is actually smaller. The shadow becomes smaller. Now let's look at this picture here. So in this particular case, this object is far from the light source. Why am I saying so? I'm just considering the distance between the light source and the object. And this object is quite close. It's near, we can see that it's near the light source. So there we go. If you just compare the two differences, you can see that they are, one is shorter and one is longer. Now, when an object is closer to the light source, more light is blocked and therefore the shadow is larger. Let's look at this. Let's go back to the diagrams before. Let's go back to the diagram. So the word shadow will represent the size of the shadow. So the more words we have, the bigger the shadow is. The less words we have, the smaller the shadow is. So the number of words, we've got 1, 2, 3, and 1 over there. So we'll start off with the one that is near the light source. So we said if the object is closer to the light source, more light might be blocked and therefore the shadow is larger. So we've got 1, 2, 3 shadows, and you can just look at the space here. That's the space where the light cannot go through, light cannot pass through, because the object, this blue object, is quite close to the light source. If we look at the picture on the bottom, the one that has the light source at a distance from the object, we've got one shadow word representing, showing us that the shadow is smaller. Now, the distance is longer between the opaque object and the light source. The distance is longer. Now, so the shadow is therefore smaller because a smaller amount of light is being blocked. A smaller amount of light is being blocked, and you can also see that the space there is also small. The space there is also small. The space is also small. Okay, now let's move on to the next slide. Let's move on to the next slide. Now, all objects absorb light. All black objects absorb light. So when you see your next black colored object, you know it absorbs light. All black objects absorb light. So no light will travel from the object to your eye. So no light will travel from your object to your eye, because all black objects absorb light. All black objects absorb light. So when no light waves reach your eye, your brain is going to interpret the image as black. So for your brain to interpret the image as white, yellow, green, orange, there has to be a wave that reaches your eye. But since all black objects, they absorb all the light, no light is going to be reflected, then no waves are going to reach your eyes, they're not going to go through your eyes, then your brain is going to register or interpret the object as black. So next time you see a black shoe, a black piece of clothing, or a black piece of furniture, just know that there's no light being reflected towards your eye, so your brain is registering that color. It is registering that color as black. Now let's look at this picture just to further explain what I have just said. So this is a person, and the person is looking at the surface. The person's brain has interpreted the color of the surface as black. Why is it so? Because the 7 colors of the visible spectrum, your red, orange, yellow, green, blue, indigo, and violet, they're all being absorbed by this surface. They're all being absorbed. Remember, we said it's either the light is reflected by the opaque substance or it is absorbed. In this case, all the white light coming in, we did 7 colors that make up the white light. They are all coming in, and no light is being reflected or is bouncing off from the surface. Then the brain is going to register as a black surface, because none of this light is going into this person's eye. None of the light is going into the person's eye. Now, your brain can interpret different wavelengths of light as different colors and can build a picture of what you see. Remember from last week, we learned about the different 7 colors that make up white light. We said these 7 colors of the visible spectrum of light, these colors have different wavelengths. Red has the longest wavelength, whilst violet has the shortest wavelength. So our brains are so amazing, they are able to interpret the different wavelengths. That's how amazing our brains are. So they're so amazing, they can interpret the different wavelengths of light as different colors, and you can build a picture of what you want to see. That's how special we are. So shiny, light-colored substances will reflect light, while dark substances will absorb the light. So let's look at this picture again. It's quite similar from the first one to the first one, but it's different from the first one. So this person is now looking at a different surface. This particular surface is yellow. The surface is yellow. Why does it appear yellow to the person? Why is the brain interpreting it as yellow? So all the other 6 colors, red, orange, green, blue, indigo, and violet, these 6 colors are being absorbed by the surface, while the color yellow, which is the color of the moment, the color yellow is being reflected. It's bouncing off the surface. So as it is being reflected, the yellow light enters the eye, and then the brain does an interpretation. Remember, our brains are so amazing, they can interpret different wavelengths of light, so it catches on the wavelength of the color yellow, and then voila, you see yellow. So that's how we are able to see different colors of different surfaces. That's how we're able to see them. So now let's talk about the moon. I'm sure we've all seen the moon up in the sky. You can see it sometimes early morning, or sometimes even during the day you can see the moon, but we can mainly see the moon at night. So now let's see, or let's learn about how that is all possible. How are we all able to see the moon and its different quarters, halves, and shapes? Okay, so the phase of the moon is due to shadows being formed. So it's all a game of shadows. Now, if we look at the moon right here, remember the moon rotates around the earth while the earth rotates around the sun. So now, these are the different quarters of the moon. Let's learn more about them. So when the moon is directly between the sun and the earth, which is, let's wait for it, this position here. When it's directly between the sun and the earth, this is when we only see the dark side of the moon, and the illuminated side is facing away from it, and we call this a new moon. So this is the type of moon we see. Then you will, next time when you go outside and you see the moon illuminated in this way, then you know that the moon's position, you know where the moon position is. It is between the sun and the earth. If you look at my rotating video there, if you look at the rotating video, once it reaches the position where marked red, it becomes dark. That is a new moon. It means that the moon is between the sun and the earth. Let's look at another position of the moon. So when the earth is directly between the sun and the moon, we can see the whole of the lit surface of the moon, and the shadow is facing away from us, and this is called the full moon. So which position is between the sun and is between this position? So let's wait for the video to get there. You see the full 100% illuminated full moon. There it is. I've got another still picture just in case you missed it. There. So when the moon is illuminated in this way, I'll call that N, then we know that the position of the moon is between the sun and the earth. What does it mean? It means that the illuminated side of the moon is facing away from us. So what are we seeing? We're seeing the shadow. We're seeing the shadow. If it looks like this, then we know that the side of the shadow is facing away from us. We are not seeing the side of the shadow. We are seeing the side of the moon that is lit. That is the side that we're seeing. We're seeing the side of the moon that is lit. Okay, let's talk more now about transparent objects. We're talking about opaque objects mostly. Now let's talk about transparent objects. Do you remember what they are from our definitions? Don't worry, I'll remind you. A transparent object is any object that allows light to travel through it. It allows light to travel through it, unlike your opaque substances. This one allows light to travel through it. What is an example? Your window pane. The window pane allows light to travel through it. That's why we need those windows that are the inside of our houses, of our classrooms, of our different buildings, can be lit very well during the day. So transparent substances, here are some examples such as glass, clear plastic, and clean water. They allow all or most of the light rays to pass through them. Therefore, they do not have noticeable shadows. They don't have noticeable shadows because they do allow a vast majority of the light rays to pass through them. So these are the substances. So transparent substances transmit light. Transparent substances transmit light. Some of it, however, is absorbed and some of it is reflected, which is why we are able to see our reflection on a pane of glass. I'm not talking about a mirror. I'm talking about a simple pane of glass that you can see through. Now, you are able to see just some reflection of yourself because some of the light is reflected, so we are able to see our reflection on a pane of glass. So most of the light energy, however, a huge chunk of it is transmitted, which is why we can see through transparent substances. That is why we're able to see through transparent substances, because most of the light energy is transmitted, even though a little bit is absorbed, but most of it is transmitted. Now, let's move on to our first activity of the day. I'm going to read out the questions, give you time to answer the questions, and then we go through the questions together. Okay, so now let's read question number 1. What is the difference between an opaque and transparent object? Number 2, what happens when an opaque object is moved away from the light source? And why do you see a black color? I'm going to give you 3 minutes to answer these questions. Then after 3 minutes, we will do the corrections together. Don't forget to send in your answers to the WhatsApp number. See you after 3 minutes. Welcome back, grade 8. I'm sure you are sending in your answers. I'm sure you're sending in your answers. So the first question read, what is the difference between an opaque and transparent object? What is the difference between the two? An opaque object or substance is one that blocks the path of light, whereas a transparent object or substance is one that allows rays to pass through it. Is one that allows light rays to pass through it. What happens when an opaque object is moved away from the light source? When an opaque object is moved from the light source, from the source of light, the size of the shadow will become smaller than the previous shadow. So it's all about the size of the shadow. And why do we see a black color? A black object looks black because all the frequencies of light are absorbed and not reflected. Therefore, no light reaches the eye. I'm going to give you a minute to copy down the corrections. I'm going to give you a minute to copy down the corrections. Okay, I hope you had enough time to copy down the corrections. So now let's move on to absorption of light. We have been talking about how we're able to see the color black or how we're able to see other colors. But what really is absorption of light? What does that mean? Now, not all surfaces reflect light, that we know. That's why we're able to see different colors. Light can be absorbed by some materials, and some materials absorb light waves or certain wavelengths from the visible spectrum. So not all of them are able to absorb light waves. Not all of them are able to absorb light waves. Let's look at this person who's looking at a green leaf. This obviously the surface is green. That is the color that you are saying. That is the color that I am seeing. That's the color that this person is seeing. They are seeing a green surface. It doesn't mean that all of the other colors are not involved in some kind of way, because we have white light coming in there and green light being the one that we see, meaning that the other 6 colors are being absorbed by the surface, whereas green is not being absorbed, it is being reflected. That is how we are able to see the color green, because it is being reflected. Now, so light is absorbed differently by different materials. Remember, not all materials are the same. If you remember from term 2, we're learning about different materials or matter. They're not the same. A mirror, for example, I'm sure all of us have used a mirror to look at our reflection. You've used mirrors before. Now let's talk more about these mirrors, this mirror situation. Now a mirror, for example, will absorb no light. It's not going to absorb any light, while a green leaf will absorb all the colors except green. So a mirror is not going to absorb any light, whereas a green leaf is going to absorb all colors except green. But then, how is that even possible? Think about what you see when you look at your reflection on the mirror. You are able to see all the colors. You are able to see all the colors. But when you look at a green leaf, how many colors can you see? you can only see one, which is green, which means the other 6 have been absorbed by the surface or by the material. Okay, so a material has color because it absorbs some of the colors in the spectrum and reflects others. Look at the color of your school uniform now, if it's not black, of course. You are able to see that blue shirt, that green shirt, you're able to see it because some of the colors in the spectrum are being absorbed, and the ones that you can see when you look at that blue shirt, when you look at that red dress, when you look at that blue pair of jeans, you are able to see those colors because that particular color is not being absorbed by the material. Instead, it is being reflected, then the reflection enters your eye, your brain interprets the wavelength, and then it decides this is the color blue. That is how colors work. Whereas a mirror, I've just pulled up a mirror now, a mirror is not going to absorb a mirror is not going to absorb any light. Why? Because you can see all the colors. You can see all the colors. When you look at a mirror, if you take all the 7 colors of the visible light spectrum, you will be able to see them because none of them are being absorbed. That's why we can also see the rainbow, because the water droplets that are in the air, when you're able to see the rainbow, are sort of acting like. Now, if some of the colors in the visible light spectrum are absorbed and the rest are reflected, then the object will appear to be the color of the reflected light rays. Think of this, the color of your shoes. Are you wearing pink shoes, green shoes, yellow shoes? The color of a car, there are different kinds of colors of the cars. We've got yellow, red, orange cars, violet cars, indigo cars. So the color that you are seeing, the color that is appearing, is actually the color of the visible spectrum that is being reflected. The ones you are not seeing are the ones that are being absorbed. So somehow all of them are busy here, but because remember the white light has all the 7 colors, but for you to be able to see a particular color, it means that color is being reflected and is going into your eye. Let's pull up that diagram that I used in a previous example. So this person here is seeing the color yellow. Why is this person seeing the color yellow? They are seeing the color yellow because the color yellow is the light that is being reflected. It is the light ray, let's just follow it. It's the light ray that is being reflected, whereas the other 6 are being absorbed by the surface. So we are able to see the color yellow. It is being reflected while the others are being absorbed by the surface. Now, an object such as a piece of white paper, it looks white. Do you ever think or try and find out why it looks white? It looks white because almost all the light in the visible spectrum is being reflected back. It's not being absorbed. So that's the difference with your black and your white. When you see a white surface, almost all the light rays are being reflected back into your eye. That's how you are able to see white. But if you see black, it means all of the light rays are being absorbed. So none of them are going to reach your eye, and which means your brain is not going to be able to interpret anything from that, and then it registers the color as black. So a black object looks black because all of the frequencies of light are absorbed and they are not reflected, therefore no light reaches the eye. So if you see white, all the 7 colors are being reflected, and then your brain interprets the color as white. If you see black, it means none of the colors are being reflected, all of them are being absorbed by the surface. Then no light is being reflected, then your brain interprets it as black. If you see a particular color, whether it's green, it's yellow, it's blue, if you see a particular color, it means all the other colors are being absorbed, whilst that one color that you're able to see, that your brain has interpreted to red, to yellow, to green, to whichever color, is actually the light ray that is being reflected. So there is just another picture to cement what I've just said about the color black. No light is reflected. None of the white light coming in. None of them are being reflected. All of them are being absorbed by the black surface, by the surface. And then when you look at it, it appears black. So next time you see a black surface, think about light rays and how your brain is able to come up with that this surface is black. Next time you see a colored surface, think about how your brain interpreted the color and then wound up sticking to the color blue. And then next time you see a white surface, just remember that the light rays, all of the light rays are being reflected, and that's how you are able to see the color white. That is how you are able to see the color white. So if you remember in the 7th grade, you learned about the radiation of heat and discovered that dark surfaces heat up quickly and they can absorb heat. Do you remember that from the 7th grade? That the darker surfaces, they absorb radiation quickly, and then when they do, the dark surfaces heat up quickly. So it's kind of like the same story here, where the black surface absorbs all of the light rays and then appear with the color black. In the 7th grade, you learned about the effect of color on the absorption of heat. White or pale colors are cooler than dark colors. If you remember that from grade 7, the white colors or the lighter colors are cooler than the darker colors. So that is because light also carries energy. Light carries energy, which causes heating at the end of the day. So all those light rays that have been absorbed by the black surface are going to cause the black surface to be warmer or to heat up faster than all the other surfaces, because it is absorbing all of the light rays. Whereas white, it's going to be much cooler than the black surface because it is reflecting off all the light rays. And then your darker colors are going to be warmer because they are absorbing most of the light, whereas the cooler colors are going to be cooler. Now, so when more light is absorbed, there is going to be a considerable heat effect. There is going to be a considerable heat effect. So when an object has a specific color, when it's orange, it's indigo, it's violet, it is because it reflects only that color of light. It reflects only that particular color of light and absorbs all the others of the visible spectrum. So look at what you're wearing today and think about it. So let's look at this couch here and the wall. So the wall is red. The wall is red with a flower pattern, but let's talk about the red part. Why are we saying that? How is it possible? Let's explain how is it possible for us to see the color red on the wall. It is because all the other colors are being absorbed by the surface except for red. And then the white couch is white. We see it as white because all the colors of the visible light spectrum are being reflected. So we can see white because all the colors of the visible light spectrum are being reflected, whereas the red wall, all the colors but one color, red, are being absorbed while red is being reflected. Red is being reflected. So absorbed colors of the visible spectrums are the one that you're not going to see. So the ones that are absorbed, you're not going to see them. You see the one that is reflected, which is red. Red is being reflected. That is why we're able to see it. We're able to see white as well because all of them, all of the white light is being reflected. That is why we are able to see the white couch, the white drawing, and the white here as well. These two white lamps. Now let's do our second activity. So this one is a bit longer, so I'm going to give you an extra minute. The first question is explain why a car looks blue. Explain why a car looks blue. And then state why everything appears to be black when you close your eyes. And then what would you see if 7 torches, it's shining light of only one What will you observe if 7 torches, each shining light of only one of the 7 colors of the rainbow, and then shine their light together on the same spot? Shine their light together on the same spot. I'm going to give you 5 minutes to answer these questions, and then after 5 minutes, we will do the solutions together. Welcome back, grade 8. Now let's do the corrections together. Explain why a car looks blue. Explain why a car looks blue. The response is when an object has a specific color. In this case, blue, it is because it reflects only the color blue and absorbs all the others of the visible spectrum. And then state why everything appears to be black when you close your eyes. This is because no light is entering the eyes. Try closing your eyes now and see the black that appears. This is because no light is entering the eyes. And then what will you observe if 7 torches, so we've got 7 torches, each shining light of only one of the 7 colors. So we've got 7 torches, which means one is shining a red light, the other one an orange light, the other one, the third one, a yellow light, the fourth one, a green light, the fifth one is shining a blue light, the sixth one is shining an indigo light, and the 7th one is shining a violet light. So all these 7 torches are shining different colors, which is the 7 colors. And they shine their light together on one spot, like one particular spot, the red torch, the orange torch, the blue torch. What are you going to observe? We are going to observe a white light. We're going to observe a white light. So now I'm going to give you time to copy down the corrections. I'm just going to give you a quick minute to copy down the corrections. Welcome back. Don't forget to send in your responses and any questions that you might have on our number. It is appearing on the bottom of the screen. If you can't see it, I'm going to read it out to you. 079-578-2908. Do not forget to also mention the name of your school. Now, let's wrap up our lesson. What did we learn today? What did we learn today? The first thing we learned today was light cannot travel through opaque objects. If you remember how we defined our opaque objects, we said opaque objects are those that do not allow light to pass through them. They block the light. So those are your opaque objects. We also learned that opaque objects cast shadows on the side opposite the one facing the light source. That's why your shadow is always behind you. If you're facing the sun, your shadow is going to be behind you. So opaque objects cast shadows on the side opposite to the one that has the light source. And then we learned that most light, it travels through transparent objects, although some light can be reflected and absorbed. And we learned that light can be absorbed by the surfaces of some materials. So some materials are able to absorb light. Okay, we also learned that light is absorbed differently by different materials. It is absorbed differently by different materials. And we also learned that a material has a certain color because it can absorb some colors and reflect others. So next time you look at a material, it could be a car, your clothing, your book, anything that has color that you can certainly observe and confirm that this is the color orange, this is the color violet, this is the color blue, green, purple. Know that this is because it can absorb some colors and it can reflect other colors. Know that it's possible. And then the frequencies that are absorbed by objects do not reach the eye. So the frequencies that are absorbed, they don't reach the eye. The only ones that reach the eye are the ones that are reflected. Now, I've got your homework activity there. I'm going to give you 2 minutes to copy down the homework activity. Okay, so take 2 minutes. I hope you had enough time to copy down the questions. Don't forget to send through your solutions to the number at the bottom of the screen. We did receive some messages from some schools. Thank you so much for participating in today's lesson. Thank you very much. And in our next lesson, we're going to be learning about seeing light and refraction of light. Until next time, don't forget to sanitize and study for your exams. Bye-bye.